So my background is I came out as an organic chemist for many years, went to graduate school for that, and really fell in love with the teaching aspect and getting outside of the lab. And so it's something I really try to carry through as I've gone into schools, to still try to keep that same experimental sort of attitude as we go in. And so I teach at the oldest Quaker school in the nation, so we've had a very rich history. We just celebrated our 325th anniversary. And so we've got a lot of history of our own to look at. And so when we're thinking about 3D in education, stereoscopic viewing has been around since the mid to late 1800s. And so I don't know for you guys, but my first instance with 3D viewing came from this little thing. And so and that fascinated me growing up. I mean, I had one at home. I kept bugging my parents to do everything. Mostly, I think, was Sesame Street related for a long period of time. But really just that idea of what does it mean now? And so what it sort of had this resurgence in schools is the maker movement that I know Liz is sort of talking about. And that's sort of how I got back into this a little over a year and a half ago, was where trying to get kids to make things, and it's always been a mess when you talk about how pipe cleaners and popsicle sticks and all these sorts of school projects that have been taking place for so many years. It's a real creative barrier, or craft barrier, as I try to call it, to making things happen, which has really changed with the tools that we can use now to do new things. And so here we are. I was lucky enough to work with Professor Robertson from the Wharton School of Business, where he teaches innovation, who has a son in our school, and we put together an innovation club for students after school. And so here he's working with some early prototypes of what's called a desk extender with one of my students who's now at USC called Dan Amchin, and I have an example of one over there. And so what we did with this is that just with about 40 minutes, we were able to teach them to use SketchUp in the classroom. And so from that, in their spare time, these kids are really able to put together some really awesome projects. And so there you can see 3D printed on a replicator that we were able to then just actually make production products. That he actually started selling these to other students in the school to raise some money for a Kiva thing that he was running. We also had a lighted pencil case that was invented by one of the students. And so we were able to have some early models there. And one of the craziest things was that one was making an iPhone case called the Yuck case, where it was so undesirably looking that no one would want to steal it. And so he was 3D scanning with 123D Catch like stains. And like we put ketchup on a table and he was 3D sketching that. And I don't think that's really high resolution for any of the Faro scanners or anything. But so this has been really a movement coming out, especially in the last couple of years. There's been a few people that have been in it longer about working with this. And so going through about 20 or 30 different maker schools around, sort of seeing what they use. And by and large, when they download things, they go to Thingiverse overall. There's a couple other resources out there. When they design things, especially K-12, there's Tinkercad is one of the main, where you move up to SketchUp when you can start getting to middle school, high school ages. I've done that as young as like 5th grade, and then you can move into some more advanced Autodesk stuff when you get towards seniors in high school. And finally, what's really been new is the whole idea of photogrammetry and being able to do easy digitization, which is just starting to break in the surface. And so to look at, there's a couple places that have been putting out models so far, and so our institute here is on Thingiverse, and they started putting up some of their scans. We have the Met, which is on the Cubify page as well, which has those out there. So it's been fun. I have a couple that I tried to print. But just to remind yourself, it's only about 80–90% success rate with printing. So you can see 2 survived on this print. 2 of them did not go so well. So it's definitely still time intensive. But so sort of thinking what we're going forward with this, what does this mean for education in general? Outside of this whole maker realm, what can we imagine where we are at a dot matrix printer when I was in elementary school, and that always messed up, and that had supports you had to remove and all this stuff. And so the idea is sort of what's going to happen in 10 years when we have something where you can send a print from home and it comes out full color, and what can we really do with that as a school? And so we're looking at really 3 ways. We look at how we can design, where we can download, and how we can digitize things in school. And so one of our problems for design this year is that we're starting a one-to-one laptop program, and there's really no commercially available solution to have point charging stations around our school. And so it really came to, like, you can have large racks where you can slide our MacBook Airs in and be able to do it, but we wanted to have something where kids can plug in, because regardless of how long these battery lives, even if they're a 32-hour battery life, kids are going to be running out in school because they just don't think about these things. And so going in real quickly, we were able to prototype, failed the prototype again, and actually come up with a solution to where just we can buy off-the-shelf parts, and for only a couple bucks plus the cost of the adapter, be able to install these in the walls around school at different places where kids want to be, as opposed to trying to tell them where they have to go to charge up. And so we're going to hopefully be installing these as we roll out more next year. Our facilities department, once they saw that, was really excited, and we have these really old shades that cover our campus, which break about at least once a week, but it's about $20 to $30 to find the replacement part to go inside. And so one of them brought me a replacement part, and in the afternoon we mocked it up and were able to print working copies that have been installed this week. So we're testing some of that. So also just saving enough money to maybe in a year or two actually could pay back the cost of our 3D printer just from that one part, and thinking about what is the other idea of things around campus that this could be applied to. And so as we look into downloading, there are some resources out there now. So working with one of our history teachers, he really wants to do a monument project. And so for sort of a test run, he said, can you get the Air Force Memorial for me? And so it's actually out there in 3D Warehouse for Google Earth. People have been doing these. And so I was able to pull the model from that and be able to print out one. So here's one of my students working with the print on our cube, and make one so that next day when he went into class, he actually had a model, and he asked the students, what do you think this represents? And so they could actually physically play around and try to think about what is the symbolism of this monument itself, and how could that help lead them to understand monuments in different ways, was a physical object. And so quite easily we had kids working with it, and this is something where you can imagine even at the beginning of the day, by the end of last class, we could have this in there. Another resource coming back from my background in chemistry is a source of protein models online. So when we talk about teaching a lot of aspects of biology, we saw a lot of great work with bones and all these other CT scans. But when we talk about molecular biology, that gets really hazy for students. And so the idea is that we can go online and get information about proteins to be able to print. What we've done in the past, though, is we've been able to make models on the computer that they can manipulate. But that's still, to many students, just a bunch of 2D images, one after another in a direction. But now we can actually print it out. And so this is actually a model of the P53 protein, which resolves in cancer, which is of great interest to one of our teachers who actually was a survivor of brain cancer and can now use this to explain cancer in a very hands-on way to his students. So you can sort of see the DNA spiral there on the left, and a group of these proteins as they're regulating DNA transcription. And so in this one, we actually have him working with, I don't know if you played it with the Leap Motion, where we can tie in the protein models on there so they can explore them, as well as having the 3D models on the desk there that we can hand out and talk about. In this case, we're doing a hemoglobin lesson where we talk about how proteins change shape due to different reasons and how that changes their function, which is something we can really not do before, and it was a very abstract concept. There are a lot of other interesting sources of data out there for those more adventurous. This is a website out of Japan called Body Parts 3D. I know there's a lot of medical information out there, but that's behind a lot of paywalls. This was not. It was just for a long time behind a Japanese language wall. Luckily, they transcribed it, but where you can go on there and find OBJ files of different body parts, bones, things like that, to be able to print out. But it does take about 10 steps to do it, so it's not for the faint of heart in the education realm. But we can definitely make, and I promised my students I'd make a pun today, that we'd have a very humorous print for them to see and play with. But the idea is, even in our talking with our athletics department about the idea of being able to build the shoulder using some of the flexible filaments to be able to make a working shoulder that we can explain to kids why certain actions they do in sports lead to more injuries, and be able to do it in a very different way of interacting with it, as opposed to just pointing to our own shoulder. We can actually give them a working model and show where the stresses happen and how they can do better. And finally, we've been working with Vince and Adam and Matt Hoffman over at the American History Museum and working with the life mass. And so this is also really fun to work with. And since I'm at a pre-K-12 school, we can really see a spectrum where for the very little kids, having the physical object is hugely meaningful. But as we move forward, one of the great partnerships here is that someone provides a lot of amazing context to this. So we have all the primary resources available to it, working with them so that by the time we get to dealing with seniors, they can look at that same object in a very different way, looking at all the portraits, bringing in his diaries, and all these other primary resources to have them tackle it and still use that same object. And so see here, here's the glow-in-the-dark Lincoln head. I don't think he glowed in the dark. There's a slight hole on the top as well, but they immediately ignore all those aspects and try to take it into dark places to see what happens. And so you can see here that how easy that is. So this is one of the great things. We have a cube printer and we have a MakerBot 2X as well, but we're so easily able to put these out there and have them build. So I put one of these building during parent visiting night, and it was no one wanted to leave my room, which actually ended up being a bit of a problem. But what's great about this too is the digitization tools, where now we can go into museums ourselves, and I know people talked about sort of democratizing this. So I have friends in DC. I used to teach in DC, so I've been down here a lot. I just go into museums and I've started doing scans myself. So this is from the National Portrait Gallery. This is by Edmonia Lewis from the mid-1800s, who was a African-American, Native American female sculptress in a very interesting time in American history. So I've been trying to connect with some historians outside to put this in context, but be able to actually have a physical model for them to explore sculptures in a very different way, to look at meaning and allow them to explore it as opposed to just showing them pictures of what we think about it. I've also started doing work with field trips, to do field trips in a very different way, where kids can come back with 3D models of what they're visited. So earlier this year, we had an architecture field trip where I had one of my sophomores. I gave him a 5-minute tutorial on how to take pictures to do photogrammetry, and he was able to come back with a pretty nice 3D model of it so that we can actually print out. There's going to be, it takes a little bit longer to repair these to make them printable, but still to be able to immediately put that on the screen and revisit what they talked about, and have the teacher be able to go back and expand and look in with pretty good accuracy about different features of the buildings that they're going to discuss. And I recently went out with 3rd graders and attempted it, and they're not as focused when they're taking their pictures to do this very accurately, but even talking about training the teachers to go along with them, and we are excited to have some prints coming back into the classroom for them soon from one of their recent trips. And kind of inspired, we wanted to take a look at documenting our own history as well. So there's a Calder statue on top of Philadelphia's City Hall, and because we are the Quaker school in Philadelphia, or the original one, we ended up with a copy that he had made of it in much smaller height. And so a couple of my students here are going through and using the photogrammetry scans, trying to do it as accurately as possible. They were excited to get out a protractor, which is not common for students. And went around with 70 pictures, and using Recap from Autodesk, we were able to come together a pretty nice model. We only had to go through and redo his hat, which was fun to sculpt. But in the end, we had little models that we can put out, and I was able to print out a foot-tall model as well on our MakerBot that we can put into our classrooms, and being able to hand out, and this is under $1 to print. And so we can put these out really easily, share them around, even just to either we're looking to raise money for a school or whatever aspects we want. It really liberates what we have to be able to share with the community in a number of ways. But of course, after we got rid of the statue out of the circle, people had to stand in. We had to start making action figures. So if he gets all A's, he gets this at the end of the trimester. But it's really amazing where you can go with this. For in this case, just while hiking out here up near Frederick, just being able to take it out in there and do scans using 123D Catch. Here's some interesting, I forget what the name of this moss was, but I was able to bring it back and talk to my biology teachers about being able to identify things out in nature and be able to bring those back into the classroom. And I know we have teachers going out across the world. We had one that came back from Iran recently on a tour, and the idea of being able to send them out to be able to capture their experiences and be able to share them in a very different way when they come back, and how to document that. And so For the monument project, one of our next things that we want to do is be able to have kids, when they come down on one of their trips to DC, actually document monuments themselves and design the monuments themselves using 3D modeling, but be able to do it where it's not all just pure their design. They can actually go find pieces of other monuments and things that they find really interesting and be able to incorporate them in to do new meaning, and to where it really also changes it because now they can work on it anywhere. Whereas before, it's sort of where the supplies were, like, and how transporting a giant diorama or other things like that gets very difficult. But now they can work on it, and we can hopefully scale up our printing a bit more to where we can be able to print these out in a fairly timely fashion once it gets towards the end of the time, so they have something physical to show for it. And especially with some fun new things we found with using Google Earth, we can actually download terrain mapping and be able to print terrain of areas so that they can put their monuments in different contexts that they want to represent. And so, yes, there's a few things where that's not supposed to be a hole there. But being able to just go through museums around while I've been traveling, being able to do 3D scans of what's in there, it's a lot that can be done without having to wait for these awesome scans. We can get our kids involved with making them themselves, or even anyone who's interested in it. While you go in, just make sure there's that photography sign and try to make sure that it's older than maybe 100 years old for the whole issue, though I know of people who do, on the slide, make scans of things that are much newer and then just don't share them to anyone. But that's definitely raising interesting aspects of intellectual property and how we're doing when it gets this easy. So really looking at the three ways we can do it is that we can really design new educational tools. We can be able to look at downloading all this wonderful information that's being created, and be able to really document our own history and how kids grow. Imagine being able to show them copies of themselves each year as they move forward and documenting their change in a very different way. So one of the things I really hope for is that we can get to a point where we can share lessons plans, and as easy as, or I guess as we can share objects as easy as we can share lesson plans. So when you come up with a really cool idea, we can have it made somewhere, but we can then have it made anywhere once the first person comes up with that. And that can really not try to add on another layer to what it means to be a teacher on top of everything else, but it can give them a lot of access where if they can do one small part, everyone can benefit from it. And so that's what I'm hoping for the people here, is to help us make this as easy to use. There's still a lot of technical barriers for teachers to use this equipment and for them to use these models, but I'm hoping that the people here can help make this super easy so that anyone can have access and have context to be able to put these to use. And so I really appreciate it, and anything that you guys have interesting projects, I love to share with students and love to make more connections, and this has been really great to start working with the Smithsonian, and I hope we can make many more connections around. Thanks.